In this lesson, we are going to look at a very important type of force, resistive force. Resistive force is a force that opposes motion. We will cover three types of resistive forces: friction, drag, and air resistance. All these are resistive forces and also sometimes termed as frictional forces that opposes motion. So let's start with friction. Friction is the force which arises when two surfaces rub against each other. In this slide, we pull a box along a rough surface. There is a frictional force that opposes motion. If an object is sliding along a horizontal rough surface, friction acts horizontally in the opposite direction to its motion. Note that friction always opposes motion and it acts along a surface, never at an angle to it. So if you have an object placed on a slope, where do you think the force of friction is? According to what we have just learned, friction acts along the surface and never at an angle to it. Also, friction opposes motion. So an object on a slope will tend to slide down. The frictional force, therefore, must be along the surface and acting upwards to oppose the sliding down motion. Why is it that sometimes objects can be stationary on a slope? To answer this question, first, we need to examine the forces acting on this box. As we have learned in previous lessons, every object is acted upon by the force of gravity that pulls it downward, and this is the weight that acts directly downward towards the center of the earth. Next, we have also learned that when two objects touch each other, there is a contact force that is acting perpendicular to the surface supporting the object. Because of the downward sliding motion caused by the weight, there is a frictional force acting along the surface. If an object is not moving on the slope, what it means is that these three forces are balanced. Hence, the object is in equilibrium. Again, as we learned in Module 1, when an object is stationary, it does not mean that there are no forces acting on it. In this case, there are three forces acting on it, but it is stationary because the forces are balanced. When we say three forces are balanced, it means the three forces adds up to be zero. That is, there is zero resultant force that causes the object to move downwards. We will learn in the next lesson why when three forces are balanced, they are all pointing in a clockwise or anti-clockwise direction. For now, let's continue our learning on resistive force. Friction acts to oppose motion. Whenever there is motion, there will be frictional force. So when an object is falling, there is a resistive force called air resistance. Air resistance is a frictional force that opposes motion. It is the resistive force that objects experience when they move through air. Air resistance depends on two factors: the speed of the moving object and the surface area of the object. Let's apply this knowledge to the case of skydiving that we have learned in the course of kinematics. When a skydiver leaps off the airplane, the Earth's force of gravity, that is the skydiver's weight, pulls the skydiver downwards, causing him to free fall at an acceleration of approximately 10 meters per square second. Because of his falling motion, there is an upward air resistance, and because he is falling in air, there is also an upthrust. However, the upthrust in air is very small, so we will focus on the air resistance. We have learned in the course of kinematics that as the falling speed of the skydiver increases, the air resistance will increase until the terminal velocity is reached. That is when the upward air resistance equals to the downward weight. What happens is that when these two forces, which are opposite in direction, become equal in magnitude, they cancel off each other. Or we say that the forces are balanced. We learned in Module 1 that when forces are balanced, an object that is in motion will continue its motion in a straight line at constant speed, that is zero acceleration. Another thing about air resistance is that it is dependent on the surface area. So when a skydiver wants to increase his speed, he will fall head down. If he wants to slow down, he will go into a spread eagle position. When he opens his parachute, his speed will reduce even further because of the extended surface area. Air resistance is sometimes also called drag. In fact, air resistance is a subset of drag. Drag has a more general scope that refers to resistive force in fluid. You will have noticed that when you try to walk inside the swimming pool, it is not as easy. You are experiencing the force of drag that opposes your motion. The deeper the water gets, the greater the resistance. If you drop a small ball into a tall glass of thick oil, you will have noticed that the ball falls with increasing velocity initially and then at constant velocity. That's when the resistive force drag equals its weight. The theory is the same as in the case of a skydiver. As the falling velocity increases, the resistive force drag also increases until it reaches its terminal velocity. Resistive force or drag is not experienced only by falling objects. As the propeller of a boat pushes water backwards, there is a resistive force, drag. As a car moves forward, there is also a resistive frictional force. Take note that resistive force, drag, is a frictional force that opposes motion. It is not the same as upthrust, which we learned in the previous lesson. Upthrust is a contact force, not a frictional force that opposes motion. Upthrust is caused by the pressure of the fluid pushing upwards on the object. In summary, friction, air resistance, and drag are all resistive forces that opposes motion. Friction always acts along a surface, never at an angle to it. Air resistance increases with increase in speed of moving object, as well as the surface area. Drag is different from upthrust. Drag is a resistive force, whereas upthrust is a type of contact force.